Alright, now what if it was like this? You're applying force to a block I'll call MA, mass A, and then that block is going to push on block B, and then block B is going to push on block C. You want to find the normal forces between the blocks. So, what's the force acting on A from the person? So talking about the normal force between the person's hands and the block. And then what's the force of A on B? And then it's going to say find the normal force of B on C. The technique would be first to treat the entire system as a unit. So ignore the cuts in the object and just imagine that you're applying that push of 30 newtons to the whole thing. So basically I'm treating the whole set as the system at the current time. Okay, then you'd want to find the weight of that system. So I'd use mg for that. In this case, it's going to be a sum of all those masses, 25 plus 50 plus 15, and then you'll multiply by 9.8. So it's 90 kilograms total, 882 newtons. Okay, you got to figure that there's going to be a normal force that's also 882 newtons. Then you got to find the acceleration of the system, and I'll do that with Newton's second law. So your net force comes from just the push alone. You divide by 90 kilograms. So 30 divided by 90 is going to make 0.33 meters per second squared. Now that you have that acceleration, you could go on to find the normal forces between the blocks. You would now change your system to now being just one of the blocks, such as I would recommend the last block. Therefore, you'd apply Newton's second law to just him. You say, okay, for block C, we have to use F net on C equals the mass of C times the acceleration of C. Okay, so plug in his mass of 15 kilograms and plug in the acceleration that you found. That makes about 5 newtons. And so that'll be the answer to one of the questions here. This would be 5 newtons. When you want to find the force of A on B, what you have to do is change your designation of system once again. And now you're only going to focus on blocks B and C together. And this is because block A is responsible for accelerating those two blocks. Talking about these blocks are being pushed by A. There's nothing else that would push them. So that is now going to be my new choice of system for blocks B and C. We have to do the F net on B is equal to the mass of B plus the mass of C times the acceleration. So you gotta add their masses together to figure out how much A has to push, 65 kilograms, and then use that acceleration they found before. It's 21.6 newtons. And that'll be the answer to this one. And when it comes to the first answer, that's simply 30 newtons. The person was pushing with 30 newtons, so that's going to be the normal force between his hands and the block A.